All right, so this lesson 17.2 is on similar figures. The rest of the unit we're going to be talking just about similar triangles, but this unit we're opening up to lots of different figures. We're going to have some quadrilaterals in there and different shapes as well. So in order for something to be similar, those similar figures or similar polygons have the same shape here, and fill in shape there, but they're different sizes. And so if it is triangles, one would be smaller than the other, or if it is a quadrilateral, one could be bigger than another. But there's two criteria to meet in order for polygons to be considered similar. First of all, the corresponding angles have to be congruent. So this is the same as our congruent triangles unit, that all of the angles have got to be the exact same measure. Let's put it into right. Congruent is just congruent. Right there. And then the second thing is that the corresponding sides, they're not going to be congruent. Okay, so if they're different shapes or different sizes, they're the same shape here, then these sides are proportional. That's why we spent our first unit solving proportions right here. All right, so the ratio of the corresponding sides. So if we're comparing one side to another, that's just what a ratio is. You compare two different sides. We call it the scale factor. And we're going to be talking about that quite a bit in this unit. So we're going to be using that scale factor. It's just a ratio of the sides. Basically, we're going to be thinking of it as a fraction, as a proportion right there. Last thing, if the shapes are similar, okay, then all their sides are proportionate. We already talked about that. The corresponding sides are proportionate, but also the perimeters are also going to be proportionate. So sides are proportionate, perimeters are proportionate. So that's that. Going on to the scale factor, let's do that in this video too, and then I'll do the examples in their own videos. But scale factor, again, remember scale factor is just a ratio of two different sides. So right here, when they ask for the scale factor, they're asking, now notice really quickly down here, order matters. So when we talk about a ratio, we can write it like this or like this. So it's either comparing one side to another with our two little dots right there, or I like it best as a fraction right there. So we're going to leave that right there. Notice right here though that your side from this triangle has to be first, or it has to be on the top right here. And then your side from the second triangle, this DEF, since it's second, it's going to go second right here, or it's going to go in the bottom right there. So just make sure that you're aware of that. And then I would just maybe say, okay, this is the first one, or I really write it as top, because I'm going to write it as a fraction right here. And then you could label your other one. You could go say DEF. Oh, that's this triangle down here. That's going to be my bottom triangle. Now, you only need one side here. They've given you all three sides. You only need one. So they've given you too much information. So just kind of whittle it down. I would say, okay, let's just look at the smallest side in these triangles. Okay, so the smallest side of this is 8. My smallest side down here is 12. So you're just going to throw that 8 in first, because that belongs to our top one, and then the 12, 8 to 12. Or we could write it as a fraction as 8 to 12. Now, they will probably prefer it if you simplify that. All of these fractions, by the way, 10 to 15 or 14 to 21, they're going to give you the same ratio. So if you simplify it, just a little bit easier to see how you could turn a 10 to 15 into that. So note right here that 8 and 12 are both divisible by 4. So just divide them by 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. And there's my scale factor, 2 to 3, or 2/3. That's the scale factor. Okay. Now, please note again, order matters. So this time they ask you the scale factor of the DEF to ABC. Same triangles, they just use the bottom one first. So now it's going to, let's see if I can change these. Now we're going to move this one down here and this one up here. So it's going to be the exact same thing. All you're going to do is put this number now on the top. That 12 goes on the top, and now the 8 goes on the bottom. Simplify and divide them both by 4, and you've got 3 to 2. That's the scale factor here. Now the perimeter, we also talked about how the perimeters are the exact same ratio. They're going to have the same scale factor is the rest. So you can either just write it down because you know that, 3 to 2, and be done with it. Or if you really wanted to go to all the work to prove that that was true, add them all together. Again, it's DEF first, so this is going to be on the top. So 12 plus 21 is 33, plus 15 is 48. That's 48 over, add all these together, 8 plus 14 is 22, plus 10 is 32. 48 and 32 are both divisible by 16. Divide them by 16 and you've got 3 over 2. So you're done with this. All right, so that scale factor, again, they're probably going to give you too much information. Just grab one side. Make sure it lines up. On this one, notice how we had the small, we could see the smallest side on both the triangles. You could also go back and just look at the first two letters. So between A and B right here is going to be proportionate to the number between D and E. So if they don't give you all 3 sides or 7 sides, whatever shape you're using, go ahead and look to see which ones should be proportionate right there. All right, last thing on this video is we're going to be talking about a similarity statement. Now, a similarity statement, so our symbol for similarity is just a squiggly mark. So remember how our congruent sign had the equal signs under it? This one doesn't have any equal signs. It's just got squiggly, just means similarity. So if we're trying to write a similarity statement, we're going to say that two triangles are similar right here. We do it the same way as we do it with our congruent triangles. First one is you just could go ahead and write ABC right there. Call that first triangle whatever you want. Notice they've already matched up which angles are congruent with which angles. So you could just go ahead and follow. A is going to be congruent to D right there. So that goes right there. B right here with the 2 ticks is going to be congruent with C. So that'll go next. And then our C, our last letter, 3 ticks, is going to be congruent to F. So those two triangles are similar. That's how we write that. All right, tune back in for our examples.